In this video, I'll show you how to use OpenClaw, N8N, and Home Assistant all running in Docker, an isolated environment, to forge the ultimate AI watchdog for video surveillance. We'll start by building the logic in N8N. First up is the webhook node, which acts as the trigger. Its job is to listen for an incoming signal from the outside world. In the settings, we've set the HTTP method to post, which is the standard practice when you want an external system to trigger an action. The path is set to check to create a unique URL for this process. Once configured, click on the production URL and copy that link. Remember, after you publish, this is the specific link you'll need to provide to OpenClaw. This way, OpenClaw can send a request to this address to tell N8N, hey, it's time to start the AI watchdog process right now. Moving on, we have Home Assistant's Call a Service node, which I've renamed to Snapshot. Its role is to command your camera to take an immediate picture. In the settings, we've selected the camera domain and the snapshot service. We also provide a specific entity ID to target our security camera. For the file name, we've given the image a custom name and saved it directly into the www directory. We do this specifically because the www directory allows for public access, ensuring that N8N can successfully reach out and grab the latest photo for analysis in the upcoming nodes. Following the snapshot, we have the HTTP request node, renamed to Download Image 1. Its job is to fetch the image we just created. In the settings, we've pointed the URL to our Home Assistant server and configured generic header authentication to securely authorize the connection. The most crucial step is setting the response format to file. This tells N8N to process the incoming data as a binary image rather than text, which is exactly what our AI needs to see and analyze in the next node. Now we arrive at the intellectual core of the workflow, the AI agent node. This is the brain that processes our visual data. To make it work, we've connected it to a vision-capable chat model via OpenRouter to analyze the image. In the settings, our prompt defines the AI's tasks and includes specific output examples, so it knows exactly how to format its response. To capture that data correctly, we've added a structured output parser configured with a JSON example, forcing the AI to provide only the keys we need: description and value. Since I often encountered intermittent issues where the AI would occasionally output incorrect formats, I enabled autofix and connected it to a DeepSeek model. If the main model makes a formatting mistake, DeepSeek steps in to repair the JSON code, ensuring the workflow remains stable and never breaks. Next is the if node, which acts as the system's filter. Its job is to decide whether the workflow should continue based on the AI's analysis. In the settings, we've created a numeric condition where the left value pulls the value from our AI agent. We set the operator to equals and the right value to 1. We configure it this way because in our setup, 1 means a person was detected. This ensures the workflow only proceeds to the notification stage when there's an actual person in the frame, effectively filtering out empty scenes and preventing your phone from being flooded with unnecessary alerts. If the logic passes, we move to Download Image 2. I simply copied and pasted it here. I tried several other methods, like using expressions to call image data from earlier in the workflow, but they didn't work as expected. This is the simplest solution I've found so far. Finally, we reach the Send a Photo Message node, which is our Telegram integration. This is the final destination where all the analysis is delivered to your phone. In the parameters, we've set the operation to Send Photo and entered our specific chat ID. We also enabled binary data to ensure the node uses the actual image file we just refetched. The most important part is the caption field, where we use an expression to link the AI-generated description. This setup ensures that you don't just get a raw image, but a complete human-like report explaining exactly what the AI saw at that moment. Now that you've mastered the core logic, you can easily scale this. You can copy the sequence within this same workflow to monitor multiple cameras at once. For even more control, you can duplicate the entire workflow for separate areas, allowing for independent schedules and customized rules. To turn this into an active agent, I used the Skill Creator tool to provide OpenClaw with a structured prompt. It detailed the task to build a new skill, specified the N8N webhook domain name, and set the camera check trigger keywords. Once the skill is generated, you'll find a new directory containing a skill.md file, a scripts folder, and a shell file. Inside, the skill.md file acts as the AI's manual. It defines the front matter so the system recognizes the skill name and description, and it maps out the trigger patterns, like check camera. The actual execution logic is handled in the shell script, triggerCameraCheck.sh. It's a simple script that wraps a curl command. It sends a post request with a timestamp to our N8N webhook. Here is where things got interesting. When I first tested Check Camera via Telegram, it failed. OpenClaw started troubleshooting and offered some potential fixes. I first did a self-check on the skill configuration, but everything looked correct. On my second attempt, I noticed that OpenClaw realized it was in a Docker container and couldn't reach the specified domain name. To solve this, the AI autonomously modified the OpenClaw.json configuration, switching the gateway from loopback to auto mode just to bypass the local network restrictions and satisfy the request. It was a brilliant bit of problem solving, but a massive security risk. I eventually reverted that change and fixed it properly by pointing the webhook to the correct internal IP. Beyond manual checks, OpenClaw natively supports scheduled tasks, meaning you can create a cron job for each skill to automatically analyze your camera feeds at specific intervals. You've now forged a scalable, containerized AI security system that thinks, troubleshoots, and guards your home 24/7. By the way, I've bundled everything from this build into a guide for you. You can find that link waiting in the description. I'm always looking for new ideas, so share what you'd like to build together in the comments. Every like and subscribe truly helps the channel expand. Thanks for watching.